Hey there! Let's get started for another video of Advent of Code 2022. Today we are working on day 10. Day 10, and as usual I've already looked at the problem statements, and this is very exciting because we are doing we are simulating some kind of CPU, so that's gonna be very at least the first problem statement starts somewhat easy. So I'm curious if the second problem statement builds on top of that. It's going to be interesting. So we are copy pasting this very small input, and we are going to start just like that our program. So as usual, I'm starting with the template that I'm using every day. I'm pasting the input in this file as usual, and the first thing I do is parsing, because it's always good to have some good parsing of the input. And here I'm going to do something very simple. I'm just going to we are splitting a new line, so instead of lines we're going to call that program, because this is our program basically. That's the CPU is going to run. And for each line, what do we want? We want to return something like const input, and we're going to do line.split with a space. And so what I'm thinking here is that we want to do rest.operation. We're going to OP is going to be like the name of our operation, and it's always input of 0. And in the case of no op and add x, it's always this. And then we can say if rest.op is equal to add x, then we can do rest.value equal parse int input of 1. Yeah, that looks good. I think I could have done some regular expression here instead of doing this splitting and if else, but I think that looks good. Let's yeah, sometimes I like to go with the regular expression. I mean, most of the time, but today I'm just like, maybe we don't do regular expression today. Okay, nope, add x, and it's 3 and minus 5. This is our input. Everything's fine. So now we can go and dive in actually the implementation of the logic of our CPU. And yesterday we've done like a class, and it worked really well. So I'm just thinking about doing that today again. So we're going to call that CPU. We have a constructor, of course, which contains, what should it contain? It should contain the program. Yeah, let's do that. So this.program equal program. So we need to remember on which line we are. So this dot current line is equal to 0 because it starts at 0 basically. What else? There's like we can make like a lot of things. We can add a lot of things. I want to stay very simple. So the thing we need to do. So there is a notion of cycle. So we need to also know this that cycle, it starts at 0. So that's one thing. And then we have a register. We have x, which is a register. Where is it? X, uppercase x. This is a single register. So we're gonna have something like this dot registers, and we just have x that starts at 0, if I'm not mistaken. Let's see. Starts with the value 1. Oof, I was about to make a mistake. I'm glad I've read the problem statement again. So here we can do const CPU equal new CPU with our instructions. I call that program here. Program. So that looks something that we want, and basically we want to do single strength during the 20th cycle and every 40 cycle after that. Okay. Okay, so basically what I was about to do, for a for loop. Oh. Let's write what I was thinking. I was thinking writing a for loop like that and say it goes until a 220th cycle, and here we do CPU dot run cycle, which is something that we need to code that thing, and then we say if the cycle, so we can say if CPU dot cycle what's happening, CPU dot cycle is equal to 20, no, so it should be 20 then 60, so there is like a cycle of 40. So what is the first cycle? Is it the cycle 0 or cycle? Let's see. First cycle, yeah. Okay, so the cycle is something that is one indexed. So it starts at 1, I believe. Let's try that. I think it's going to be, for the current line, the cycle, the register, we need to be very careful with off by 1 kind of errors, where we just do a mistake of 1. So if CPU cycle modulo 40, how does this work? Modulo 40 is equal to 20? Is that it? 1, 2, 3. Yeah, so here, same. I need to check, I need to be careful. There might be an off by 1 error here. But basically, if we have that, console log CPU dot cycle. You know what? Here, I'm just going to do that. CPU dot cycle plus plus. So I'm just actually, I need to it starts at 1, so let's try that. Okay, 20, 60, 100. Okay, so that's correct. So maybe we actually put CPU cycle plus plus at the beginning. Yeah, because we run the cycle. That's gonna be. Let's create this function. Run cycle. And here for now, it's just do CPU.cycle plus plus. That's the only thing that it's doing. So now we can actually use run cycle. And here we display the cycle. Okay. This looks correct. So yeah, we're just gonna check that with the input, and we're gonna see if it works or not. Yeah, before all that, here I need to do something here. I can't just say a run cycle and it's it does cycle plus plus. We need to do something with register, we need to do something with the program. So here we're going to check, first of all, I'm going to say if this.current line is above or equal this.program.length minus like that, you return false. Otherwise, we return true. So basically, here we make sure that when we are at the end of the program, we just stop. So here we can do something like if not run cycle, then break. And basically we can do, here we can just do while true. So run the program until the end. That's what's happening. We do an infinite loop and we make sure that we continue to run the program until we have arrived at the last line of the program. Yeah, there's like a lot of little features that we need to bring together in order to make this CPU class work. So now I am at cycle, this.cycle. I am at the current instruction const instruction is equal this.program of this.current line yes, I think that's basically it. So we have the instruction. So here we can say switch instruction case no up. We just break. So here, do nothing here. I just put a default case, throw new error unknown instruction. So actually here this is like a more line. And here this is line.op. Because we want to know this thing, if this is add x or no up. So unknown up. Line.up. Okay. Case, and in the case we have add x. What do we do? Oh, I have sometimes the autocomplete that's just annoying me. So add x. So basically we need to wait one cycle and then increase the value. So here we're gonna have to have a new state in our, this is basically a state machine. This wait equals 0. Here we do if, oh, I made a mistake. Here, the no up, we need to do this.current line plus plus. That's very important. We need to go to the next line because no up is, we read the no up operation, we do nothing, and then next cycle we are reading the next line. That's very important. Here with add x, we need to check if this, so that's funny. How? So there are several cases. When we are on this line, first of all, we need to do this dot weight equal 1. I'm not sure. I think it's time to like take something to draw. Okay, so the state that we are, we arrive on add x. What we need to do is to we arrive on add x, then we wait one cycle. Oh, this should be here. Wait one cycle, and then we actually add the add x value to the register. These are the 3 steps. So when we arrive on add x, we need to set a flag to wait. Okay. That's it. We're gonna set a flag this. So if this dot wait is equal to 0, then we wait one turn. Otherwise, this dot wait minus. If this dot wait is equal to one. Basically, here I'm taking the idea, I'm writing this code if we so that we can wait more than one turn. That's the idea that I'm doing. Maybe it's not a good idea, but yeah, that's what I'm doing. That's why it's a bit more complex. Maybe that's what it needs to be. This dot wait. So basically, we arrive here. This dot wait is set to 0 at first. So the first time we do, okay, we set 1. So basically, we are not doing anything else. Then the next time wait is equal to 1, so we are arriving this condition. Wait minus, it is equal to 0. So this is running, and this is saying we actually do the operation here, and in the end we do this dot current line plus plus. So here doing the operation means we do this dot registers dot x plus equal this dot line is equal line dot value. That's what we want, line dot value. Because we have already the data that is parsed in our program, we know this is an int already, and in case up is equal to add x, we know there is a value that is set. So here we change the value and we are done. We go to the next line, and that should be it. And if we go after the last line of the program, we just return false. This is handled here because we then break out of the cycle, and we say console.log. We're done here. Let's run that. Oh, we didn't see anything happening. Oh yeah, of course, because here we should, for now, we're just gonna console log the cycle. No, not the cycle. We don't care about the cycle. We to console log cpu.registers.x just to see where we are. So we start at 1. Then after the first cycle, we have 1 again. Start of second cycle, we wait, it's still 1. Okay, then it is 4. Then it's still 4. Then it's -1. And we are done. Okay, so we have something that's correct. Now we need to check, is this logic working? I think we are most likely off by one, like there is some most likely mistake. So we're gonna fix that by just running this long program. I mean, it's not super long, but it's not 3 lines. Oh yeah, it's 146 line. Let's run that. Oh, we are displaying CPU cycle. This is not what we want to display. I believe we want to display the strength. Oh, we want to multiply the cycle by the register X. Okay. CPU cycles time CPU dot registers.x. We can actually display everything. I like to do that. When debugging, I display the cycle, the register, and then I display the multiplication. So 20, 21, 420. Okay. Can I just copy paste that? Because I hate when I jump from one window to the other. Let's do that. We just copy paste that here. 21, 420. Yeah, I think we're good. We are good. So that's good news. I was convinced there would be like some kind of error here, but we are good. So now what we need to do with this is to sum all of these. So that's easy. We just do let sum equal 0. Here we do sum plus equal this full thing, and I can actually remove this line, and here we display the sum. Okay, is that correct? Yeah, that looks correct. So let's jump and take the full puzzle input. Is that correct? Oh yeah, 140 lines. That's very close to the example. That's weird. Is that correct? That is correct. Great. Let's go to part 2. I'm gonna pause and read the problem statement. Okay, so this is gonna be fun. This is gonna be not easy, but I think like what's hard here is that the problem statement, yeah, it's just like there's like a lot of information, and here you have to make sense of this information. I think that's the hardest part. And I think here we want to create another class just to make sure we keep the two things separated. We have the CPU on one end, and we have like the CRT screen on the other end. So I think we're gonna do that because we don't want to write one big ugly piece of code. So let's do that. Let's start here because actually we don't need this class for the first thing. Constructor. What do we have here? Have a screen. So we draw. So let's do this dot width. We make something that's very flexible, you know. Width, height. This is currently 6. So actually we can do width, height, and here we can say width equal 40, height equals 6. So that here we can reuse width and height. This okay. It's gonna be interesting. This current index is start at 0. Yeah, and here we also have something that's called a run cycle. except we need to know the register. How do we call that? The register value, or how do they call that from the screen point of view? The sprite position. Okay, sprite position, and here we need to know the sprite width, and it's equal to 3. Yeah, there's like a lot of information. As I'm telling you, basically the sprite is like a block of 3 characters, and the middle position is the same as cpu.registers.x. So the middle position of these 3 characters is defined by the register x from the CPU. And we need here to do something, and then we do this dot current index plus plus. And in order to do that, console log, we're just gonna display that and sprite position. For now, we'll just do something very simple. So we're gonna reuse our code from the previous part. Here we don't really need a sum. We do need to do that. We don't need this anymore. Run cycle. Here we do need a CRT. Here CRT new C. Is it CTR or CRT? CRT. There is no. We don't need to pass anything because there is a default width, height, and sprite width. We remade everything very flexible. And here we do need to do CRT dot run cycle with the CPU dot registers dot x here, because this is the position of the sprite, and we use the position of the sprite here somehow. And then at the end, we need to display the full screen for us to see. So here we do need to initialize the screen. This dot screen. So the content, maybe we can say content, because it's already this is already a class for a screen, so we need to initialize the content. This is new array. The size. We're gonna do this. The height. As you know, I like to fill with 0 and then do the map. Otherwise, if you don't do that, you end up with an array of undefined, and I think the map doesn't work, so that's why it's good to use this fill.0. And for each line, what do? We need to create a new array of this.width, and this one we have to fill it with what is this? A dot. We fill it with dots. Yep, that's it. So here we're gonna say print screen. So console log, we just have to do this dot content dot join with the line return, and I think that's it. Cause no, this is an array. Okay, no, my bad. So we need to map line, and we do line dot join with an empty character, so that this is each line is converted to a string, and then we have to put the string together with the line return, and that should be it. So before we do, actually we can print the screen. CRT.print screen. And we print the screen in the end, and here we should see just a screen of empty characters. Yes. Why do I have all this noise here? It's because of this line. Okay, we have our empty screen, and now we need to do stuff on this screen. So in this method, we need to know on which line and which value I am. So basically this index is just one variable, but we need to know basically on which line we are. To do that, we're gonna say this dot line. Or we can do this dot, no, not this actually, we can say const x is equal to this dot current index. We have to do modulo this dot width and const y this dot current index divided by this dot width, I believe, and here we can do math dot floor. So basically, when current index is between 0 and 39, this is 0 and this is between 0 and 39, and then when it's 40, this becomes 1. So this becomes 0 and this becomes 1. Yeah, I think that looks nice. So now we need to check. If this dot current index, so we need to do the distance between x and the sprite position. That's what we care about. We care about math.apps x minus sprite position. And if this is 0, it means we are exactly on the sprite. Here we need to actually use the sprite width, otherwise it's all for nothing. So sprite width is 3, so you know what? I think sprite width is not going to be a parameter of our class, otherwise it just makes everything super complex. So if this is below 1, below 2, I think that's correct. The distance between x and sprite position should be at most 1, so that we are inside the sprite. Because remember, the sprite, we have the position of the middle of the sprite, and then there is like one character on both sides. And if these characters are overlapping with the position x, then we can do this dot content dot y dot x equal hash. Let's see what's happening here. Oh wait, do we have, I'd like to use the test input first, because I don't want to see the end result like right away. If this is not working, we're gonna have like some very bad stuff displayed. Some random things. Okay, it looks like we are not correct, because yeah, we are not correct. That's good somehow, because we can fix what we made wrong. Let's think. Cycle. Oh, actually, we can display print screen. Let's say that if here we're gonna crt dot content of 0. We're just gonna print the first line of the crt, the join with like that. So basically we're gonna print this first line that we see what is happening. So the first cycle we have this, and the second cycle we should have again this. How come? No. You know what? Here we're just gonna break. Here we're gonna say if this current index is above 10, process.exit. We're just gonna do like this the hard way so that we don't have like a ton of lines, we just have very few lines. Current index is equal to 0. The sprite position, oh, I think there is an off by 1 error. Because I think here, what is this here? Position 0. Yeah, we have most likely an off by 1 error. Because sprite position, it's a 1 indexed the sprite position is 1 indexed and the current index is 0 indexed. So if we do sprite position -1, let's try that. Is that the same thing? So basically we should have cycle 2, we should have this thing. So we have already an error there. So let's forget about this thing. We should have this current index, X, and sprite position. Sprite position is 1, X is 0. Sprite position is 16 already? Oh, we are not good. So I believe CRT must run before here. Okay, that's better. Yeah, see, we start with the 2 hash. That's typical kind of off by 1 errors. So then what do we have? That's what we have. So I can remove this. We can go full. We just remove all this debugging. Oh, that looks a lot more like it. Yep. So basically I was running the first cycle, but we need the value of the CRT using the register before we run the first cycle. That's just a small thing, but that's quite important. I don't know if we need to do that here again. Actually, here we can do console log cpu.cycle and crt.cycle. Let's just display the end result. Oh, crt.cycle. We don't have a cycle here. We have current index. Current index. Just to see, do we have a dead pixel in the end? How do we know that? Current index dot I think there's just one way. We run that and either we are out of bound, we see an error, or we are, if we do that again, I think we're gonna have like an error. No, we don't have any error. Oh yeah. So else this.content equal a dot. Yeah, I think that's even better to do that. We're just gonna fill with spaces Yeah, that's the way to debug this error. We just fill the full screen with spaces, and either we display a hash or we display a dot. And so we're gonna see what's happening. We are already too far. Console log yx. Are we already too far outside of the screen? 6-0. Yeah, we are too far outside of the screen. What should we do when we have that kind of thing? Is the screen... Yeah, we're just gonna, I think, maybe drop it. Here we're gonna display CPU dot cycle. We had cycle 241. I think this is the last cycle. So here we're just gonna check if y is above this dot height. Return. We don't care. We don't want to go and do something outside of the screen. Oh. Okay, so it looks like we are good. So we can remove a lot of the console logs. We have filled the full screen with what we care. We can actually run full input. I feel quite confident. Let's see. Is it misplaced confidence? Oh, it's R. Okay, we have some letters. That's good. Let's try to see if this is correct. So here you could write something to read the letters, but to be honest, I think this is not part of the challenge. You can read the letters by with your human eyes. So let's see. I've copied the letters. We can paste them here. This is another star for Advent of Code 2022. Thank you so much for the support in this series. Thank you for all the comments, the likes. If you haven't subscribed, do it. You'll see the next videos. And yeah, thank you for all the good vibes. See you in the next one. Bye bye.